opportunities that come with an ever-increasing digital landscape. We will hear from the industry and the research worlds just how important data and new digital platforms are and how they are being optimized to positively impact the supply chain. We have three panelists, Matthias Perkagen, Luc Martsen, and Andreas Metzger. They will give their presentations in a row, and they will have like 30 minutes for Q&A. I kindly ask you to write your questions in the chat so I can address them to the panelists at the end of the presentation. So I think we can get started. The first panelist is Matthias Perkagen that will present Elo Group's digitalization journey. Matthias is the Logistics and Supply Director at Elos Group AB in Sweden since 2017. He holds a master's degree in logistics from the University of Borås. Prior executive positions to Elos include Vice President at DHL Freight in Sweden, responsible for the 3PL storage operation in Sweden, Head of Operation in NLY Scandinavia AB, Quality Manager at Bring Parcels and Express AB with the responsibility to implement a common strategy for quality, Logistics Manager at Bring Parcels AB as part of the management committee establishing a new organization with new tools to support the quality work, and Logistics Consultant at ProFlow AB. Matthias, please, the floor is yours.
Thank you. Hopefully you see my presentation in a good way. If we go,
not in the presentation mode.
No, it's coming. Elos Group is a company based in Sweden with focus on the Nordic market. We have 4 brands in our portfolio or in our group. It's Elos, Jotex, Stay Hard, and Home Room. We were established in 1947 in Sweden, so we're a quite old company. Coming from the mail order business and going into the e-com business, I'm going to talk a little bit about during my presentation. Basically, we have 60% that we are selling is our own brands, and we're working with a group with several different brands within the group. What we say in Elos Group that we are an e-commerce platform. So what it actually means is that all 4 different brands within the group is acting as their own companies within the group. And all the different brands are focusing on the product portfolio, what they're offering customers. They are owning the customer, the knowledge of the customer, and the branding towards the customer to attract the right customer to each different brands. And of course, the different brands are aiming for different customers, have different offering within fashion and home. And all of these brands are backed by Elos Group, backed by a shared, well-invested, scalable e-commerce.
Yes, excuse
platform.
me, we're seeing your notes. It's not in the full screen. If you can change to presentation mode, thank you.
Okay, it is in presentation mode.
It's on the display settings. You should be able to click down and change to present.
If you go to the top, Matthias, there's the drop down in display settings.
Swap to present.
Then you can swap.
There you go. Is it better?
Yep, perfect.
Perfect. So the different brands are backed by the Elos Group e-commerce platform, where we have payment solution, financial services, we have the CRM, we have marketing, product management and design, we have sourcing, we have logistics within the group. That platform has the strategy of being as scalable as possible, have a good cost efficiency, but also a high degree of digitalization within the expansion of the group. What has this transformation meant to Elos Group? Coming from mail order going to an e-commerce means that going from a catalog, paper-based, going to digital and mobile. The catalogs were a lot of juicy promotions, and the e-commerce is strong brands relations. Mail order was more a strategy, while e-commerce is a more culture. And there's been a lot of different programs from this journey. Of course, a lot of different cost out, competence shift. We have changed a lot of employees during last 6 to 7 years, going from catalog competence to e-commerce competence. We have also resulted in a lot fewer headcounts compared to where we were 2014. We have rebuilt all the offices from being one office for each employee to now have open space. It's white, it's fresh. We have a lot of the socializing areas. We have also been rebuilding the culture, the values. We have also made one of the biggest investment in the company history. It's going from a mainframe system with all the development in-house to best of breed tech setup, where we invested a lot of money to put the best system in each position. And this was actually done with a big bang 2017. And of course, 2021, we are still working on making it even better. So it's a continuous work going forward as well. E-commerce platform, how does it work? So first, we have this state-of-the-art front end. That's the core of our business, is where we meet the customers. And we see quite increased when it comes to mobile shares. It's around 75–80% today. So we are all the time working with the best state-of-the-art technology. We're working with personalization in the site. We're working with speed, site speeds, etc., optimizing all the time. We are also working with the CRM, the customer database. There we have some different tools. I will come back to that one. Everything is in-house built, machine learning to be best prognosis of what the customers actually are going to buy and what they would like to buy, but I'm coming back to that one. We also have a scalable logistics. So we have 2 different warehouses, one for small goods and one for really bulky, heavy goods for home. And we also here working with the supply chain. And we're working in a lot of projects at the moment, trying to increase the supply chain visibility, also last mile and visibilities. We're working with real-time data in our production to follow up customer promises, to follow up efficiency, etc. All of this platform is also scalable, so we should be able to acquire more companies and put it into the group with a quite short lead time implementing. But we can also start up new brands within the group. And that's also something that we did with Homeroom, which we launched 2018. After 2 years, it has a revenue of 100 million Swedish kronor. We have also implemented Stay Hard, was one of the companies that we bought a couple of years ago. We have recently launched the European market, 4 markets in Europe, which we did within 6 months. And we're starting with Utex as a brand, but we will also launch the other brands into the European market. And all of this should be backed up by our e-commerce platform and the backbone behind it. We also have, which is quite unique, we have our own payment solutions, which is called Ellos Pay. So we are offering the whole front end, the whole solution, technical solution ourselves towards the customers. Then we have a partner behind us, a bank, for all the transactions, etc. We also have a shared sourcing group looking into the sourcing from China, Europe. We also have dropship platforms that we have set up. So a lot of our sales comes from partners from us. We're shipping from their warehouses. We also have a digitalized sales platform together with our partners there, so we can handle the processes and the flows together with them. And that's a bit on top. We also have, which is quite strong, our own in-house marketing automation platform. So what we're doing is that we're taking a lot of big data inputs from different sources into our own in-house built recommendation engine, where we're using machine learning. And that machine learning is looking on the customer behaviors, looking at the data, where you are when you're on social media, etc., what you like on Facebook, etc. Based on that data, we do some product recommendations, brand recommendations. We actually do some quite advanced calculation of which customers we should address with which products, which brands, in which social medias, etc. You see the different recommendations and personalization priorities to the right. And also in the next step, we are going also to adapt our homepage based on you as customers coming in. Customer X will have one homepage looking like certain products coming up, while me will have other products coming up when I go into the homepage. So this is also what we're working quite strongly with, the data understanding of customers' behaviors. So that was a little bit from Alice Group, transformation journey in 5-6 years within 50 minutes short presentation. Of course, there's a lot of other interesting things around this, but I hope you got some insights of it.
Thank you very much, Matthias. It was very insightful. And I see we have a couple of questions. We'll take them at the end, okay? So thank you. Don't forget to write your questions on the Q&A. And we continue with our second presentation by Luke Marsden, who will present the role of digital platforms and technology in facilitating good management of scientific data. Dr. Marsden holds a PhD in geophysics from the University of Leeds, investigating the link between magma ascent and the formation and seismicity using quantitative data analysis and numerical modeling. He is currently working at the Department of Arctic Biology, University Center in Svalbard. He is the lead data manager for the Nansen Legacy Project, Norway's largest research project. The Nansen Legacy Project is a multidisciplinary project that investigates the impact of climate change on the Barents Sea. His responsibilities include ensuring that all data and metadata collected in the project are appropriately logged, linking physical samples to searchable databases, ensuring that all metadata and data are compliant with the fair data management principles, publishing scientific data, advising researchers on data management, and developing tools that facilitate and simplify good data management. Luke, please. The floor is yours.
Thank you, Fabiana, for that very thorough introduction. So yes, I'm Luke. I live in Svalbard and work at the University Centre up here. As Fabiana said, my role is mainly employed through the Nansen Legacy Project, where we investigate the role of climate change on the northern Barents Sea. And so the project is built around these large cruises that go several times a year. And I was lucky enough to join them on one of those cruises in February. You can see me here, the third one from the left on the top, and the guy with 3 hats on. It was pretty cold. And today I'm going to talk to you about how we have how the digital platforms that we've developed and the technology we use facilitates good management, which is vital in all projects, but in particular in projects as large as this one. And a lot of credit has to go to my predecessor, Paul Ellingson, who really developed most of these tools in the introductory phases of the project. And I'll talk to you about how we've taken things from there. So firstly, why is good data management important from a research point of view? Well, in my opinion, data is really a researcher's legacy. Academics publish papers that, unless they're particularly high impact, they're cited and read for perhaps 5 or 10 years after publication. Whereas the data that one publishes could be used and contribute to science for decades into the future. Despite its importance, data are often unavailable. According to a study by Gibney and Van Noorden, 2013, about 80% of data are unavailable 20 years after the publication. This is for a variety of reasons. Either data gets lost or misplaced, or the people that are responsible for the data move on and perhaps if they haven't stored data appropriately, the data that they have left is not understandable. But it's not just the data that we lose, it's also the information about the physical samples. Many research institutions around the world contain fridges that are full of unidentified samples, and if we don't know what they are, there's really no point keeping hold of them. And we now live in a world of big data, where we're working with more data than we ever have done before. And it's difficult to manage all of this manually. And so this is why digital platforms and automation are really important. So we plan ahead and develop tools that can help us manage data in an efficient, effective way. So the National Legacy Project, we look at warming and the effect of global warming on the Northern Barents Sea. And because of feedback, positive feedback loops, Northern Barents Sea is one of the fastest warming places in the world. It's warmed about 4 degrees since the 70s. And this means that it's not only interesting to look at the effect of this climate change here, but it's also then a case where we can investigate what further warming elsewhere around the planet and look at what effect that might have on ecosystems. It's a large project. It's probably still Norway's largest multidisciplinary project. It contains over 200 researchers from 10 different research institutions. When we go on multiple cruises, up the transect that you can see here on the east coast of Svalbard. It's hoped that several of these stations will become standardized stations that will be visited in some way in the future and can enable long-term monitoring of fixed points. It's a multidisciplinary project. So we have biological cruises, one of which finished yesterday, where they sample different fish and different sea life. But we also take physical measurements through oceanography or meteorology. This is one of my colleagues lowering ADCP into the water through the ice and measuring temperature, depth, and the conductivity of the water. And being multidisciplinary, it's very difficult then to log and manage everything in a consistent way. So we'll talk about how we manage that. And as a project, we're committed to the fair data management principles that were proposed by Wilkinson and a long list of collaborators in 2016. They suggest that the data should be findable and accessible. We're pretty good at that now in academia. It's often a requirement when you publish a paper that the data are published in some data repository too. But that doesn't necessarily mean that that data is understandable. So we say that the data should also be interoperable, meaning that it's able to be used with minimal manual intervention and reusable. So how do we achieve all this through the project? Well, to do this, it's really important to have a consistent way of logging everything and everyone using the same system. So we have a virtual machine that we deploy on board the ship. And this is accessible anywhere just by plugging an Ethernet cable into your laptop. Through this virtual machine, one can generate templates to enable a consistent logging of data. There's checkers to ensure that the templates are filled in properly. Tools to help print, to attach labels to the printers, labels to the samples, sorry. And there's documentation that researchers on board can access to help them with all this. What's also interesting are the sampling protocols. Just a quick word on these, because I think these are quite useful. We have published sampling protocols that are agreed upon by all the researchers within different parts of a project. And this means that if you have 2 different people and 2 different cruises working with the same data, you can be assured that the data is been collected in the same way with the same methods. For researchers that log their data in standardized templates, we have a generator which can be used to create these templates with some required terms that we require for every single template sheet that someone fills in, and some recommended terms. But there's really a whole host of other terms if you scroll further down. Each of these terms are taken from standardized common vocabulary. Most of these terms are then from Darwin Core, which is useful for logging biological data, in particular biodiversity data. But we also take terms from NetCDF CF conventions, which is more suitable for oceanography and atmospheric sciences. And so ensuring that everyone is using the same column names means that firstly, everyone understands what is contained within those columns, but also it then makes it a lot easier to convert your data into standardized formats from these files. We collect a lot of samples, so we ensure that every sample is labeled. We have label printers on board the ships. And what is important is that each sample is logged with its own universally unique ID or UUID. This is a 32-digit hex number. The hex number is digits 0 to 9 in the first 6 letters of the alphabet. And it can be represented as a data matrix, as you can see here. And because these are universally unique, there's very little chance of collision. And so you can be sure that someone can identify each sample uniquely and search for them in the database and retrieve exactly what they're looking for. When it comes to logging these samples electronically, it's easy then to scan these data matrices in. And the advantage of, well, one of many advantages of logging data electronically is that you can include far more data and metadata on an electronic log than you can in on a label. It's also then accessible from anywhere. But also in the future, if you find a sample in your fridge and it's got one of these labels on, you should be able to scan it and find out exactly what it is. But we don't just log physical samples. There's also cases where samples are disposed of on the ship, or perhaps no physical sample is taken at all. Maybe we're measuring the temperature of seawater or something. In that case, we still log the metadata electronically, and then we have a UUID generator on board the ship, and someone can just copy and paste this. After each cruise, the data gets sent to me. It's my job to do a little bit of cleaning and make all of this searchable online through a portal on our webpage on SciOS.org. This provides a single access point to the data, which provides then an overview of all the cruises. So if people both inside and outside of a project can get a good feel for what has been collected on each cruise. You can then identify a single sample. You get a map showing where the sample is or has been recorded. And all the metadata that's been logged relevant to where the data was taken, who's responsible for the data and who to contact, and what actually the sample is. Another important point is that we have a hierarchical system for logging all of our data. So, for example, you might have some activities at the top of the pyramid. This could be a deployment of a single trawl net, for example. And below that, then you have samples and then perhaps subsamples of that. So it could be some fish, which are then subdivided for different research purposes. Then we have a parent-child relationship between each of these. And so this is really useful in being able to group data together and see how everything relates and navigate through the data set. If you set your database up in this hierarchical way, you can then also propagate metadata from parents to their children. So for example, we know that all the samples from a given activity should all have the same coordinates. So instead of relying on this being logged appropriately for each sample, you can just log it for the activities and propagate it downwards. And then because we're also logging the parents along with the sample, you can also identify where parents have not been registered in the database. And you can set up scripts to do all this and search for this automatically for you. When it comes to the data themselves, we also make all of this data available for a single access point on SIOS. All the data is supposed to comply with the fair data management principles that I outlined in the beginning. Whilst the data are not stored on SIOS themselves, we make this data, we provide links to the data repositories. So as long as the data has been tagged with the project name in the data repository, we can feed this into our portal, and one can then navigate to that data. And just some final remarks and some learnings from what we've taken on from this project. It's really important to have a good plan and to start well in advance of the project. We have a documented data management plan, which is published. This is really good for assigning responsibilities, who's responsible for what, and if things are not kept to, who can you contact, and who can you hold accountable for this if it ever comes to that. But communication is another important point, and something that I never realized would be such a big part of my job as a data manager. We're constantly in data management trying to convince people to do things that they perhaps see as low priority or don't want to do at all. So having good communication skills to remind people of why it's important, and providing regular trainings on how to do these things is really important. This is also easier if you minimize the chances for human error and minimize what people have to do. So you can automate things. All of our tools are automated and open source, so we share those and they can be used for future projects. Having templates rather than ensure that everything's standardized, and where possible, remove the chances that someone is going to type something incorrectly. So having a drop-down list rather than a free text field can be very valuable. And everything we do is open source. And I think, this is the way we're going, but hopefully we've showed you some nice ways here and about how to share your data and the metadata. But what I haven't gone into too much detail is the tools that we have available. They're all available on GitHub and are being used by some smaller projects. And if anyone ever wants to develop on top of these, and that can be done, get in contact with me. So thank you very much for listening, and I'll take any questions at the end of the session.
Thank you, Luke. Very interesting and very cold, seems to me. We will go to our third panelist, Andreas Metzger, who will present how data and AI can transform transport and logistics and enable new insights. Dr. Andreas Metzger is Senior Academic Counselor at the University of Duisburg-Essen and heads the Adaptive System and Big Data Applications Group at Paluno, the Ruhr Institute for Software Technology. He holds a PhD in computer science. His background and research interests are software engineering and machine learning for self-adaptive systems. Andreas was technical coordinator of the European Lighthouse Project Transforming Transport, which demonstrated in a realistic, measurable, and replicable way the transformations that big data and machine learning can bring to the mobility and logistics sector. In addition, he was member of Big Data Expert Group of Picasso, an EU-US collaboration action on ICT topics. Andreas serves as steering committee vice chair of NESI, the European technology platform dedicated to software, services, and data, and as deputy secretary general of BDVA, DARO, the Big Data Value Association. Andreas, please.
Thank you very much, Fabiana, for this kind introduction, and also already introducing the project, which I go a little bit into more detail, Transforming Transport, the Lighthouse project, from which I brought some nice illustrative cases for how data and AI can indeed transform transport and logistics and enable new insights. Let me share my slides. I just have to find the button. Here we go. So I'm going to do three things here in this presentation. I'll have the agenda here. So I'll start really showcasing concrete examples for how you transform logistics with data and AI. Go into some lessons learned and challenges that came out of this project, understanding where research opportunities may lie. And at the end, try to connect with the research infrastructure discussion of this conference to see how research infrastructures may help in supporting the digital transformation and the even improvement of transport and logistics. In a sense, this means I kind of have two angles in this presentation. So the first is looking at what, logistics could do for research infrastructures, in a sense, by improving logistics, making it more efficient and reliable. But on the other hand, then I'll flip the coin in a sense and look at the potential opportunities for having research infrastructures to do some logistics experiments and innovation. I understand this is not the typical research infrastructure that may have been discussed at this conference, but I thought it could bring a little different point of view into these discussions beyond this Large Hadron Collider and impressive research infrastructures we saw. Okay, let me start a little bit with what has happened in transport and how we can leverage the opportunities there. So in the last 5 to 10 years, I would say the amount of data which is available to observe, monitor, and control transport processes has increased dramatically, in parts because you have the IoT, you have the instrumentation of devices, manufacturers started to push all the data they had from their trucks and trains and cranes, making it available to do nice things with that. And this gives an opportunity to really leverage this for advanced AI mechanisms, talking about machine learning, deep learning, where you can really in real time, on the fly, analyze, monitor, and better have an understanding of what goes on in your processes, in your transport chain, and even predict future situations to proactively react. And this was a little bit the outset we had at the beginning of the Transforming Transport project that Fabiana mentioned, which started in 2017 with really an ample number of data assets and quite some data volume, which was lying around there, which was collected, which was stored, which was not really used to improve the operations and the maintenance and the management of transport. And in this project, we brought together 46 partners across Europe, major logistics providers, major infrastructure providers, ICT researchers, so really a multi-dimensional project. Also had some decent funding, I have to say. And we looked at 7 transport sectors: road, rail, maritime, ports, and so forth. And in each of these, we looked at 1 or 2 pilots, which really demonstrated what's the value that is there in the data. We didn't spend much time to make a perfect data integration platform or data sharing concepts. We really said, let's do a little bit like Agile, right? We have an idea what could be the purpose of the data, what can we do with it, and we really very quickly created demonstrators to also show to the transport operators the value behind the data. And what you see here is a kind of collection of the main insights we had of what is the value behind the data. So if you look at the roads, we were able to have much more accurate traffic predictions in order to prevent traffic jams by rerouting traffic. We were able to have 17% faster truck deliveries. So one of the cases was from Amsterdam to Frankfurt, one of the big highways, which is always congested, and how we can manage this flow. Looking at the infrastructure, the transport infrastructure, we were able to do predictive maintenance and indicate an up to 34% less maintenance costs by doing this proactively and not regularly. The same for the management of port equipment, 10% cost reduction there. And then in the end, looking at the end user, so the personal mobility, we were able to improve the throughput in the customs clearance or security clearance in airports. And for the supply chains, reduce the distribution vehicles used for local distribution of goods by 38% by doing a clever assignment and sharing of the loads. So these were really kind of very motivating insights about the power of the data. And have a little more concrete examples here so you get a better feeling for what was done. And this was happening on really different levels. So one of this was the infrastructure maintenance. We had a partner from UK Rail, which was having a hard time making sure the rails are maintained in a way that it's both efficient, but also with low failure rates. And they used the ample amount of data they had from specific devices to predict at which point in time would it make sense to go into maintenance for parts of this infrastructure, not to be too early, not to be too late. And really were able with intensive data analysis to find the hotspots where they should do things and provide the maintenance crew really up to the date information where they should go to. Another example, I had this before briefly, is the prediction of passenger flows through the airport in order to better kind of manage the security gates. So you don't want to over provision them because it's too expensive, but you also don't want to under provision them because then you have the queues. And so if you can do this with a really high accuracy prediction away of time, you can really make sure that this can be better managed. In a sense, a similar analytics approach was followed for road management, where you want to kind of avoid the queues in front of the toll lanes, and there we want to do some load balancing between them. Third example is really more in the operations. So how can we improve the day-to-day operations in transport? And one example we looked at here, one pilot, was a port close to our university, one of the largest inland ports in the world. And there we were able to predict the flow of containers in the terminal, and were able to anticipate where there may be a problem, a delay in the container flow, and thus a delay of the subsequent supply chain. And this allowed us to increase the efficiency of this terminal and the throughput by around 5%. Let me drill down a little bit into this example. So as I said, it's located as an inland port close to our university. It's in the city of Duisburg. And the challenge there is that the port, and you see an aerial view here, cannot really grow in space because there's a city around it, there's roads and stuff around it, so it's a very densely populated area, so not much ability to grow in space. But what was possible is, of course, to improve efficiency and thereby increase the throughput with the same fixed space which was available. And this is an example of what really was available, and I mentioned this in the beginning, by an intense digitization of the port equipment. So you see things here which we looked at in this terminal, which are some transshipment tracks, so connecting to the public train infrastructure. You have the cranes which move the containers. You have the trucks which come in and deliver containers. You have towing vehicles which can stack containers, and all of these devices were fully instrumented. You got the real-time location, you got additional information, and this led to something like 1.3 million data points a month, and we were able to analyze them, aggregate them. One simple example you see here on the right-hand side, that's the utilization of the terminal space, and you see it's very crowded here, meaning lots of containers stacked, whereas below here there's not much, so there's already an opportunity to improve the use of space in the terminal. But the more interesting thing then was the operational support. So what you see here is a snapshot of the so-called terminal productivity cockpit, which allowed the terminal operator to, in real time, see the status of the trains, how the containers are loaded, but more interestingly, also get a prediction when our machine learning black box thinks the processes are complete, so the containers are fully loaded to the trains and the trains can leave the terminal. Together with an alarm if there's a delay predicted, and some level of reliability, how certain is the machine that this prediction is true. And with this, we really were able to significantly improve the efficiency in the terminal, because you could reassign personnel staff to the critical parts, you could reschedule elements in your processes. So that was kind of the first start of the story, and this is where this project ended. But what happens now in research and also in AI and machine learning is to start moving further. So not do a really kind of a support for analytics, observation, and predictions, but really make the machine take autonomic decisions. So instead of the dashboard you saw before, where the operator, the human in the loop, still has to decide what to do and whether to act, the trend is now to also give this fully to the machine in the term of some advanced control. Technologies like reinforcement learning to solve complex planning tasks are one example here. And I think this is where it really also gets interesting for potential future research infrastructures, because so far there's not much ability to test these systems except you put them in the wild or in a virtual simulation. So there may be a need to really have a physical test infrastructure to play around with these concepts and notions. So very quickly, some lessons learned. I'm a little bit quicker here because I think we're starting to run out of time. So one key element in all this digital transformation, even though data sounds very nice, is one problem is data quality. So it's this nice garbage in, garbage out problem. And what you see here is just one example of a completely different benchmark data sets from another application domain, but this was collected with 5-year distance, bad data collection, good data collection, and you see a more than double jump in accuracy just by changing the quality of the data. And there's other nasty things like you have to agree on the clocks and synchronize things and various kinds of problems. So it's great to have data, but you have to be careful. You cannot just use it out of the box. The deep learning mechanisms out there, and you see many of the success stories even in the daily press, it's really impressive what you can do. It's a little bit expensive from the training side because it burns an awful lot of computing power. May take also quite some time until it works really perfectly. And in the end, then you have this nice black box I said before, which may give you an indication 80% sure that this is a good prediction, but it doesn't really explain why this should be a good prediction. And obviously the trend here is to do this in an explainable fashion. Again, the question is, what is a good explanation? What would help the user? Other elements is once you have data, you may always have too many data, and you enter into the problem of how to present and visualize this to the decision makers. Yeah? So there's many ideas, simple widgets, aggregation, but the question still is the visualization and the amount of data you show to the user on the right level for the target at hand, the task at hand. Last point is, I mentioned these 100 so-and-so data sources at the beginning. On average, we had like 10, 15 data sources per pilot. You have to integrate them. So you have to agree on semantics, common meaning of the different data sources. One of the data sources may talk in their coordinate system in GPS coordinates, the other in a completely internal coordinate system. The information about containers, what's in the container, the contracts for the containers may completely be different in the different systems. So you have a significant amount of time. In our case, in the project, was 80% to do this data integration and understanding. And a very clear trend now as part of this big data value partnership in Europe, where BDVA is one of the private driving forces, is to set up domain-specific platforms. So where you can use established semantics architectures, you can integrate data from different stakeholders. You can integrate it in a way that data protection is ensured and that you can also really exchange data in a traceable form. Very interesting activities there, and it's also visible in the next round of work programs to push forwards to the so-called data spaces. Okay, with that, I'll come to my last slide, connecting to the research infrastructures. I mentioned this already a little bit. So what I would really like to see as a kind of researcher in transport and logistics is you could call it test bed, you could call it research facility to really play with these new opportunities. And as long as the opportunities were just on the monitoring analysis side of things, not a big problem. As soon as you want to have the machine close the loop and make automatic actuation, it's probably good to have a safe environment, sandbox kind of thing in the physical world to play around with that, right? So that would be great to have some infrastructures to really experiment with these new concepts in transport logistics. This also would include then doing experiments on trustworthiness and maybe even the public perception of what AI can do for you and how strong AI influences your daily lives. And finally, another important point is you also have to consider the skill pipeline. So also for the researchers, you always have to have access to recent information and also maybe provide a digest of the essential information because it's growing exponentially, but also for the end users to understand what the technology can do for them and what are the limitations. And with that, I close with some pointers to maybe further papers if you're interested in this whole big data ecosystem or the specific solutions we created in the project, and acknowledging our sponsors, of course. Thank you very much.
Thank you, Andreas. Very interesting how really we can use data to leverage logistics in general, port operation, and so on. And with that, thank you very much for our insight and very, very interesting presentations by the three panelists. And we can, I think, go to the Q&As that we have quite some questions. Let's try to browse them and see, and we address them, you know, as in a round robin fashion, let's say. Let's start with Matthias. First question, what about open space and COVID-19 pandemic? You know, it reminds me that today we were talking about coming back to our offices, and we have now like an hybrid fashion mode, and so we're all aware of, you know, how we work in these new open spaces and so on.
Yes, yeah, of course, we have been affected by COVID for sure, in several areas actually. One is especially our fashion, of course, started to decrease when the COVID started. All clothing for fashion occasions, etc., concerts, everything was dead. But instead outdoor shoes, sports grow instead. But our home interior has been expanding enormously. So people around the Nordics have redone their homes. So we have had a really good boost from the COVID situation. And all of this we have done with 90% of all office people working from home. So of course, we have seen the explosion of Teams, usage of Teams from workshops, etc. But we experienced it. It's been a good time, even though we have been working from home. But we also see that it's a challenge for the culture. For us, culture is extremely important. That you meet and greet with people, you have some experience when you're meeting in the social area, etc. So that has been a challenge that we see a lot of people that wants to come back and that spend a lot of time off the office as well now. And we are also looking into how our new world will look like after the summer. The summer, of course, we will have more work at home, but still we will have most of the time at the office again for sure.
Thank you. This is a question for Luke about the tools. Who developed the tools? Are these out of shelf? There is a limit to the amount of data handled. Yeah, I was wondering also about the amount of data. Andreas was talking about big data. What about what kind of assessment of the amount of data you are talking about?
Yep. So these tools were originally, well, the template generator was originally developed by people working at GBIF in Norway. That's the Global Biodiversity Information Faculty or Facility. But this has been then very heavily developed by my predecessor, Paul Ellington, and myself. In terms of all the database management, again, we have developed that all ourselves. It's all developed in Python, and it's all on the GitHub page and able to be used by anyone else who wants to pick it up. In terms of the amount of data, we deal with probably tens of thousands, if not hundreds of thousands of samples. But in terms of limits, I guess it depends how you code it. We certainly never had any problems with that amount of data, but yeah, I don't think there's an upper limit depending on how you code these systems.
And all data is open source. I mean, everybody can use the data sets that you are actually putting there.
Well, the metadata comes straight to me from a ship, and then I can make that available a short amount of time afterwards. The data themselves relies on the scientists actually then converting the data. And so there's a bit of a big part of my job is trying to convince them to actually publish that. So some of them are better than others, and we're getting there now. But yeah, but we publish the data then in data repositories and make them then available through SIOS. So in answer to one of your other questions, the data are published in a number of different data repositories, mainly in Norway, but they're then accessible from anywhere.
Thank you. Question for Andreas. Who managed the machine learning for the port? Was this a company with expertise that came and helped out?
In the end, it was my research team at the university together with Software AG, because they provided some of the tooling. We used a very modern form of machine learning, LSTM, so it's a recurrent neural network with many layers, which was not yet part of the tool chain. So we started with a kind of foundation and put on top the LSTM prediction models. In the end, this was not the biggest problem, as I pointed out. And I think nowadays you get many of these things even out of the box already, and you can deploy them. The real challenge was understanding the data, both from the domain point of view. So what are all these different concepts and notions? For example, what's a twist lock on a crane, right? This is the little device that hooks the container to the crane. So I mean, starting with all these terminologies was a key point, because this is in the end reflected in the database or in the data sets, because you always get the status of these different physical elements in the chain. And so in the end, this was really taking us 80% of the time, many meetings, many interactions. Once this was clear and you came out with rather structured data, feeding this into the machine learning pipeline was the easier part, with some tuning to get the accuracy right. But the first step was really the challenging one.
Thank you. Matthias, you mentioned change of culture in this transformation between catalog versus internet. How was that achieved? Did people retrain, or was it new staff?
As I showed in the presentation, we are today around 450 employees in Ellos Group, and we were 900 2014. So of course, there's been e-commerce versus catalog doesn't drive that much people as catalog did. But we have also worked a lot with the new IT system. We have actually, after we implemented the tech structure, we brown papered all our processes and rebuilt them to make them as efficient as possible, because in our business, it's a tough margin, so we don't afford too big costumes. So that's also a work that has been done. But of course, a lot of people has left us during this journey. At the same time as a lot of new people has been coming in. So also there was some percentage asked about, but that's hard to say. But of course, in some areas, there's been 100% new people. In some areas, it's been 50-50. For example, logistics is easier it's the same, almost the same, if it's e-com or mail order. In some areas you pick and pack the same products, while in IT, of course, in some areas you have completely putting in some new people when it comes to front and mobile applications, etc. So it varies a lot dependent on in which department you're looking at. But of course, we are today more new people than old people.
I guess it was a major cultural change besides,
Yes, it's been a struggle, because old meeting new is also a culture struggle. It's not for example, from a logistics perspective, we worked 7 to 4. It was 5 to 8 days lead time for orders. Today it's 2 to 4, and we are working more in the weekends. We are working in the evenings. We're working 9 hours in the Monday, 7 hours in the end of the week. So a lot have been changed during the process, and of course that has been extreme challenge to rebuild the culture. And I think it's a challenge both for the old people and for the new ones. It's all about meeting in the middle and somewhere, but that's also why we have done a big job around the company culture. We rebuilt that due to this change in process going forward. But we are still challenging the culture, and we're still developing. So it will be a continuous transformation journey going ahead. It will never stop. It will just continue, because it will pop up some new competences, new IT systems. In 10 years, we will probably have some other competences than we have today. So it's a long transformation journey that never ends.
Yeah, continuous transformation, endless process, I would say.
Yes.
Thank you. Look, there's a kind of more technical question here. What software is being used for sample tracking and metadata information, and who developed it?
Yeah, so again, we developed the tools. So the metadata are initially logged in Excel templates, just because this is what people are most familiar with using. We then take the data from that, and I clean the data sets and publish them into or deposit them into a Postgres SQL database, which then we host online.
Thank you. Andreas, for you, what measures were taken to raise the efficiency in customs clearance?
Very good question. I think I have to apologize here. I was speaking so fast that I was carried away. I didn't mean customs clearance. I meant actually security clearance for people at the airport if you go to the security lanes. But still, to answer, what we did is we had an accurate prediction of the passenger flow. So we could really anticipate when the customers or the passengers would arrive at the security gates, which is not so easy, because you would think that you can anticipate this because you know everybody's flight and when he will leave from the airport. But people have a interesting distribution on how they arrive at the airport. So you have many people arriving very, very late, and some others in this long tail before. So it makes a little bit difficult, the prediction. In any case, based on the prediction, we were able to kind of reschedule the which of the lanes were open, and then reassign also staff members to the different lanes, because there's a certain lead time, of course, to reschedule the staff along these lines.
Any of the solutions you developed in the scope of the TNT project are in use, or just they are still in the
Yes. No, we had 2 or 3 real success stories that went now into production, and one really interesting one I didn't show actually was from the coordinator Indra, Spanish tech company, a very large one, and they developed a very nice idea that you could use the fiber optics cable along the highways as a sensor, so not as a kind of communication device, but as a sensor, because you can really measure vibrations through the fiber optics cable. And thereby you had something like thousands of sensors on the roads, and you could precisely manage the traffic flows, traffic jams and stuff. And they now turn this into a product together with according data analytics parts, because you get lots of noisy data and lots of complex data. And they had some image recognition tools now that can tell you where are traffic jams or accidents in real time. So it's quite impressive. Another one was from Smart Vehicles. So there's a small company in France who has dongles for the cars, which connect to your service bus inside the car. And they use this to do recommendations for fleet management. So suggesting how drivers should change their behavior in the fleet. We did it on the fleet level because of data protection and not on the individual level. And this, I think, is also now going towards a product in the end.
Cool. Matthias, this is a very interesting question. If you would do the consolidation again, what would you do differently? Looking back to the past, and to the future.
Yeah, what should you do differently? We have talked about that several times for sure, but doing a big bang with, I think it was 15 new system in one big bang was a challenge. And I would say if you redo it from that perspective, because that was one of our main milestones in doing this digital transformation to e-com as well. I would say that perhaps we should have done a little bit more competence shift around IT, challenge a little bit more about the solutions that you put into. In some cases, we took what we did before and put it into the new costume. And in some cases, you should have challenged it more, use more of the standard in the IT systems, and also try to, in some cases, rebuild some of the systems, because that was what we have done the last 3 to 4 years, that we have rebuilt some areas of the tech platform that we probably should have done differently when we did the Big Bang. But of course, when you do a transition journey and it takes 3 years to change an IT platform, a lot happens during those 3 years. So suddenly you choose one system, you're starting to implement it, and in 3 years it's not top of your mind anymore. There's a new system that's much better. So it's always interesting to be smart afterwards, but in some cases at that time it was the right decision, but you have to be open-minded that you can throw away the old decision and make new decisions along the road, and you can make it 2 months after you have implemented the tech structure. You can redo and change some systems, and that was a challenging task for us internally to accept in some cases that shit, this is old-fashioned already now. We have implemented 2 months ago. We need to have a new system in place, and that was when we brought in some new people that came in with some new ideas and saw this, for example, the mobile systems in another way than we did 4 years ago. So I would say that a lot can be redone and rethought, but at that time, 3 years ago, it sounded good, but 3 years ahead, it's completely different picture that you're looking into. So it's hard to say exactly what we should redone, but I think challenge a little bit more around all the processes where we should be had been something that we have taken with us during this journey.
Did you rely at all on an IT internal department, or it was an outsourced project all in all?
Almost everything was done with internal resources. So we used the guys and girls who made the mainframe system to implement the new platform as well. But of course, there were some new consultants from the system suppliers, etc., that were into this project as well, of course, challenging us. So we both consultant and own resources, but most of the system today is run by our own resources. And in some cases, when we design solutions, we bring in consultants.
Thank you. Luke says here, do you send your data to other repositories for increased spread? How do people find your metadata catalog? I guess if anybody wants to use your metadata, what they should do.
Yeah, the metadata catalog is accessible via the SIOS webpage. And the data themselves are also accessible via that page, but are published in different data repositories for a broader spread. So you can access it through that and through SIOS, and it's linked then to each individual repository where the data is stored.
Andreas, this is I think an academic question. How should an organization start with AI, and how do we identify problems that would be suitable for AI solutions?
Oh, that's a very good question. I would I would answer, I think AI is not always the solution or the answer to your problems. So I would start with the questions you would like to answer, and then check whether the data provides you with at least some indications that this could be answered with the data. It may be that the data is not sufficient, so you have to go back to data collection, because usually data is not collected for the purpose you have in mind. This was one of the lessons learned also we had in the project. But once you understand the real question you want to answer and you go back to your data collection, you will probably make a huge step there. Then the next step is, do you really need AI or machine learning, or at least some of the very advanced things, or could you do even with much more simple, like statistic approaches, which have the benefit that they may be much more traceable, understandable, and maybe also require less, let's say, intensive technical expertise to set all these pipelines up. At the end, you always have this, I would say, engineering or design trade-off between, do I completely trust the black box to take the decisions, to find the patterns, to learn what it should learn, versus how explainable, interpretable will the things be that I built. And what happens in AI at the moment is that you completely forget your domain knowledge. You just throw data at the box and you hope for the best. Now I'm over exaggerating. But in many of the application domains, in transport and logistics, for sure, you have lots of domain knowledge. You understand your processes, you know the typical process flow, and you don't have the machine necessary to learn everything from scratch. So I think there's a important trend now also in machine learning research and industrial AI towards this hybrid AI, bringing in explicit knowledge and combining it with data where it makes sense and is sufficient. So I guess I didn't really answer your question. It was not possible because it's so multifaceted, but I think this should give you some food for thought, I hope.
I don't know whose question was, but I have a follow-up question actually. If you, I mean, you're a researcher and looking into the future, what do you see as the next AI in future steps? Let's say, what is in the future? What can we expect?
So I think there's a very clear trend to what is called embodied AI, so that your AI agent can interact with you like a human person, and you can really start asking questions, interacting with the AI. This is especially interesting also if you talk about explainability. So explanations are not a single shot thing, right? I mean, you don't have the box tell you this is the reason why I came to the decision. Explanations are social and based on interaction. So you get an indication and then you ask questions back, and then you get a new answer and you maybe ask questions back in order to gain insight. I saw a very nice showcase from a colleague from IBM yesterday at the software engineering conference, where they now also use this embodied AI to fine-tune their cloud services. Kind of say, okay, if I change this parameter, what would happen? The AI come back with the simulation, and then he can really have a dialogue with the AI. And this is, I think, very, very impressive, because you have this learning cycle. Not the one I showed, where the AI basically has this control loop in the real world, but you have the learning cycle in how to configure and interact with the AI, which is quite impressive.
Yeah, it's actually very, very hot topic in IBM now.
Yeah, I can imagine, yes.
Matthias, would the RIs benefit from sharing the platform for users and or logistics?
Yes, I would say for us it's a little bit challenging now going forward, because we have a shared platform, and we, from a logistics side, we would like, for example, to have big products in one warehouse to scale the efficiency picking and packing. But when we are growing and we need more warehouse, we need more cubic meters, and we are also expanding in Europe, which has been quite good success at the moment. You're challenging the platform, because suddenly, because we have 4 brands, should you split up the brands? Like we have carpets just in one warehouse, but for all brands, or should we get one brand in one warehouse to keep all the products together in one shipment towards the customer? So a platform is good in some areas, but when it comes to the customer and we are growing, it becomes a little bit challenging how we should work going forward. And that's something that we're looking into now in a good way, how we should reach that. But otherwise, internally working with a platform and sharing the different developments is beneficial from all our brands. We have forums where we meet all brands together with the group functions, where we, for example, have a customer forum where we look at the customer friction, what we can do together, benefit from all different brands. We also have a sourcing forum when we go through all brands and the sourcing. We also have e-com forum where all the different brands meet together. Because when you have a scalable platform, you can't do everything of what the brands would like to do, because you need to do the things that have the best business cases and can be most scalable to all brands. So of course we do some prioritizations during the way what we should do and not to do. And that can also be challenging internally, because all employees think their ideas or their developments is the most important, of course.
I guess. Thank you. And look, how much of your annual operational budget is dedicated to data management and scientific computing?
I don't know the numbers for this, but I think it's not so much. I mean, the project as a whole is a big project. It's about a 70 million euro project, depending on the conversion rate. In terms of big expenditures from a data management point of view, I guess there's my wage. I'm the only full-time data manager employed by the project. There's some other people who work in an advisory sense, maybe get a little bit of money from that, but not too much. And then there's things like buying labels and printers, which they're expensive for labels and printers, but in general terms, they're not too expensive. So I don't think it's a big budgetary cost necessarily. And in terms of the processing and the computing powers, in Norway, we have a national infrastructure for research data, which is free for scientific research data. So we can store data and share it internally in the project. And there's high access to high performance computing through that as well. So yeah, I don't think it's a big portion of our budget.
Okay, thank you. Andreas, is a question about the systems that are needed to do the analysis of the flows or processes.
Okay. So I think there's two answers to that. So if you talk about the business processes that we tried to monitor, for example, for the ports, there's two kinds of tools you can use. There's the so-called process mining tools that allow you to also reverse engineer, if you wish, the process model from the data. So you have an understanding of how the principal flow of goods would be and what are the typical steps in between. This is usually not perfect because the data is not perfect. There may be even an alternative to do this manually with a domain expert. So again, back to this trade-off between let the machine do the stuff based on data or ask the people who should know how it's really working. For the predictive part, this is, as I said before, machine learning tools which are out there, which are usually open source based on TensorFlow or what have you, typically implemented in Python, not so really nice code if you ask me as a software engineer, but it's really working and efficient. So this is the tool that you could use in a sense to throw data at and then create a prediction model with which you do the prediction.
Great, thank you. I think that we have only one question left, but I think we also answered it, which is that the software in ELO, if it's developed in-house or outsourced, and I think that Matthias already answered that mostly is done in-house. So I guess we're really a couple of minutes before time, so I think we are great. It was very, very interesting. I liked a lot the presentations and also the questions. Thank you very much for the questions and mostly to the panelists. And I think that's all from my side.
Thank you, Fabiana, and thank you, panelists, for contributing to all of this and the audience for raising all the questions. Jürgen, as always, at the end of the panel, I ask you, are you happy?
Extremely happy. I can say that digitalization is not the strongest card I have up my sleeve, but seeing this, it's a real asset. So Matthias, the answer there, if it could be for something for the RIs to go strive for, I still think we have to go that way and investigate it anyways. So again, Andreas, regarding the test environment, let's talk further about that because that could be interesting as well.
So,
thank you.
Then we have come to the end of our panel presentations, and what's happening next is that we do have one last session, and that is an interactive one. And for that one, everyone will now receive a link. I think, Madison, you're going to send it out in 1 minute time as a reminder, because there we would like to ask you to dial into another Zoom room, because there we would like to have a very interactive and open conversation with you, where we would like to collect your feedback and your input for how we basically could continue this initiative and how we can carry it forward. So with that, we are looking forward to seeing everyone back in the new room and the new link at 2:30. And then we'll do some interactive sessions. And this is exactly the Zoom link that has just been sent out. So you all should have received an email by now. So thank you very much for all your contributions, and see you in 15 minutes in the other Zoom room. Thanks very much,
Perfect.
everyone.
Thank you so much.